Hi Zoe. I wanted to explain to you how you can get exact values in right triangles. Usually we only ask for exact values when it's a special right triangle, like a 45, 45, 90 right triangle. So if we know, for example, that this is a 45-degree angle at a right angle, then by subtracting from 90, that angle would have to be 45 degrees as well. So if we know this side is, let's say, 5, then we can find all of the other sides without using trigonometry. So we don't have to use sine, cosine, or tangent here, because we know since both of those are 45, this one would have to be 5, because in a 45, 45, 90 triangle, both the legs are the same. And then use the Pythagorean theorem to get this side. So that would be, if we call that x, then that would be x squared equals 5 squared plus 5 squared. So x equals the square root of 50. And that is equal to 5 root 2 when you break that down into 25 times 2. Square root of 25 is 5, square root of 2 is 2. So now we have that this side is 5 root 2, and that is exact, whereas if we used sine, cosine, or tangent, we would probably get a decimal value for that. You can do the same thing with 30, 60, 90 triangles. So if this was a 30, 60, 90 triangle, and let's say we knew this side down here was 4, then a 30, 60, 90 triangle is half of an equilateral triangle, because that would give us 60 there. 30 and 30 at the top is 60, so that's half of an equilateral triangle, so that would be 4. And now we can see that if this side is 8 going all the way across here, then these would have to be 8 as well. And then you could use the Pythagorean theorem to get the third side. I'll call that h, and so it would be h squared plus 4 squared equals 8 squared. H squared would be 64 minus 16, so h would be the square root of 48, which is, in this case, that's 16 times 3, so we could say square root of 16 times 3 is 4 root 3. And so now I have the other side in the 30, 60, 90 triangle. I have that exact without using any decimal values. And so those patterns exist in every 45, 45, 90 triangle. These two sides are the same, so if we say that those are both x, then the hypotenuse is always going to be x root 2, and that comes from the Pythagorean theorem. So it's the same as what I showed up here in the first problem. The legs were 5, the hypotenuse was 5 root 2, and it'll always work out that way by the Pythagorean theorem. You can try it out with different numbers and you'll see that that works. For a 30, 60, 90 triangle, it always works that whatever the short leg is, the hypotenuse is always twice as long. Remember I said here we had 4 for the short leg. That's the short leg is across from the 30-degree angle. Smallest leg is across from the smallest angle. And so when you double that, we got 8. And so here, if the short leg across from the 30-degree angle is x, then the hypotenuse is twice as long. And then using the Pythagorean theorem, this would always work out to be short leg times root 3. Okay? So then applying those concepts, if we had a, let's say we had a 45, 45, 90 triangle like this, and I know the hypotenuse is 10, I can go backwards. We said if the leg is x, then this has to be x root 2. Those would both be x. And so then if you solve that, you'd have x is equal to 10 divided by root 2. You could leave it that way, or that could also be simplified to be 10 root 2 over 2, which would be 5 root 2. Okay? In a 30, 60, 90 triangle, if I know that, let's say I know the hypotenuse is 20, then that makes my short leg 10. My long leg is always going to be root 3 times the short leg, so that's 10 root 3. So I have all 3 sides now in exact format rather than using decimals. So it only works for those 2 special right triangles, the 45, 45, 90, and the 30, 60, 90 triangles are the only time that we can get exact values. Hope that helps. See you soon. Have a good break.